Hello, welcome back to Daily LeetCode Live, where I do daily LeetCode questions, raw and uncut. So let's get started. So today's question is count number of bad pairs, and well, whenever we see something like bad pairs, beautiful array, something like that, we always want to find the definition of that. So you're given zero index integer array nums. A pair of indices ij is a bad pair if I is smaller than j. Let me turn that off. And j minus I is not equal to nums j minus nums I. So let's look at the example. I think like after that I kind of get what the question wants. It's not too clear what we have to do, but well, the other thing I noticed is that the length of the array is 100,000. So that means we are aiming for a ON or n log n solution. Uh, Anything more than that, like n squared, would be too slow. So let's look at the example to just consolidate our understanding of this. So we have this array 4133 here. So the output is 5 here. And the explanation would be the pair 0, 1 is a bad pair. Well, yes, because like 1 minus 0, so the two indices is not equal, well, to 1 minus 4. So that's a bad pair. The pair 0, 2 is a bad pair. So it's the same logic. So yeah, so this question is pretty easy to understand, I guess. But we still have to figure out how to actually do it. And like the difficult thing of this is definitely that we can't brute force it, so we need to find some like nice ways to make this faster. So let's think about like what we definitely have to do. Um, so well, the brute force. Well, let's think about the brute force way first. Actually, if we are brute forcing, then sure we can just check every pair. So where can we cut down that like maybe redundancy, I guess. Like where can we do that? So that's what we have to figure out. And the other idea I thought of is that like finding bad pairs are kind of hard, like are kind of like harder than finding the opposite. So the good pairs. So the pairs that like that j minus I is actually equal to nums j minus nums I. Um, so we can think about that as well. We know that like if we have like X amount of um, good pairs, and we can calculate the total number of pairs um, in the array. The bad pairs would just be the total number of pairs minus well, the number of good pairs. So finding good pairs and bad pairs are kind of the same thing. Uh, yeah, so that's just like one idea I thought of as well. Um, I couldn't like really like see the solution straight away, so maybe we can get drawing and we can see if we can think of anything. So to optimize like the n squared brute force solution, one way you can do it is like you can make a quick check for each index, or maybe even uh maybe even for each indices or something. um like we kind of group, like we basically like slowly build up from the left, like so that's one idea I thought of. The other thing is maybe um maybe normalizing like the array could also help, although I don't quite see. Well, I mean, like when you normalize it, it would be good for like something like 1, 2, 3, 4, 5. But what if you have like uh oops, like 1, 3, 4, 5 and you normalize it to 0, 2, 3, 4. Well, this still works, but well, we couldn't really tell just by normalizing it, obviously. So let's think about other ways, maybe. Hmm. Yeah. Well, let me have a think first. And also, like, I think the concept of my video is that I do it like uncut. So there will be moments that I actually have to think about how to solve it as well. Like, I haven't seen the question before. So yeah. Well, let's think about like example one. Like, is there any like quicker way of doing it? Um, hmm. Actually, if we so let's look at the formula. So we have j minus I is equal, well, to nums j minus nums I. And well, this is for good pairs, right? For good pairs. So can we rearrange this formula to make it something better or like easier to deal with? So can we like turn it around maybe? Well, let's try to find out what we can do here. So actually, what if we rearrange like j to one side and I to another side? I'm not sure if that will help, but maybe? I'm not convinced. But let's see how this formula helps. So what this means is that for each index, we can kind of map them like into this kind of thing. So like into this formula. So for oh, I think I got it now. So um so how we do this is we kind of use this formula, right? So j is the index, this is the actual number. So let's map it so that well, we can turn this formula into nums j minus j equals nums I minus I, right? That makes sense, right? So if we can do that, so that means we just have to check whether after mapping each number and subtracting it by its indices, we can just check whether they are like any number are equal. So I think like when I explain the solution, it's like it might be a bit fake or hard to understand, but if I give an example, it will definitely clear things out a lot. So what we want to do here, so we have the indices here, so 0, 1, 2, 3. We want to do the element minus the index. So that's the mapping we want to do. So that means we will get 4, 0, 1, 0. And because of this formula, we just have to check how many of them are equal. So so we have a 0 and a 0 here. So that means we have like like one good pair here. So why is that one good pair? So let's look at the formula again. Well, we have like 1 and 3 here, right? Like for index 1 and index 3. And well, it does make sense, like when like this will work with the formula, like it will be a good pair instead of a bad pair. So yeah, like actually when we look at the original array, well, yes, the only good pair in this array is 1 and 3. And like basically after this mapping, it becomes whether they're equivalent, like because of the like the arithmetic stuff I did here, that basically allows us to do this, to basically uniform like the distance, or like the like where the elements are. Yeah. So I guess it is still a bit fake, but yeah. But what that means is we just have to, like, we can definitely count the number of good pairs now, solely by the number of the same elements. So if we have one element, so like if we only have 1 4 like in the mapped array, well, that means only that number after the indice, like after the index mapping, um can get to 4. So it wouldn't form any good pairs with any other numbers. If we have 2, well, we can form one pair because, well, remember here, like it has to be I is bigger than I is smaller than j, so we wouldn't double count. So I think like a few days ago we have a question that uses the arithmetic sum. I still don't remember what that's called, but um so basically the formula is like number of good pairs for that number, so for the specific map number. Well, what is this equal to? It is equal to the count of that number. So the count of that number, actually let me write down the arithmetic sum maybe. Yeah, so it is the count of that number, so count of number minus 1, and the count of number minus 2, all the way to 1. So why is that? So let's say we have like 4 3s. Well, this first one can form 3 pairs with the 3s at the back. This one can form 2 pairs, and this one can only form 1. So if we have 4, we are basically doing like 3 plus 2 plus 1. That's basically what this like badly variable named equation means. So yeah, it basically became like just getting a counter for this mapped index, like with this index mapped array, and for each count we can calculate the number of good pairs you can form with that number. And how many, like, how do we find the total number of pairs? Well, it's kind of the same logic as what I did here, right? So if you have 4 numbers, well, like let's say 4 1 3 3, well, the first number can form 3 pairs, the next one can form 2, and then it can form 1. So, well, it's the arithmetic sum as well. And yeah, so that's kind of the solution. I hope my code kind of explains what I'm trying to do here. But yeah, let's get coding. So index map. So index map nums. So what do we want to do? We actually want to like have something here for I in range. We should really have n here as well as the length of nums. We use n because that's just usually what they give, and well, it could be more descriptive, but n is fine, I guess. Range n, and well, if we think about our map here, what do we want to do? We want to do like the number minus the indice of the index of that number, right? So we want the number minus the index. So that is our index mapped nums. And after that, we just want to get a counter. We want to count how many numbers are in each, like how like we want to count the frequency of the index map nums basically. So free of map nums, and we use counter. So again, LeetCode will have they will have automatically imported that for you, but it's still good practice to write it out yourself, I guess. So index map nums, and now, well, we just have to loop through each of the value. We don't even care what what value it has. We just want to know where it is equal, and like we can find the good pairs here. So find all the good pairs, and actually before that, we want to find the total number of pairs. So total pairs. Well, what would that be equal to? It would be equal, well, so I remember like we can like the formula for like 1 1 plus 2 plus 3 all the way to n. There's a very well known formula called Gosh. I forgot how to say his name. But that's the formula. And like basically what you do is like you flip the whole sequence, and then you get all the way to 1, and then if you sum them up, you get like n plus 1, n plus 1. So how many n plus 1 you get? You get n amount of n plus 1. So you have n plus 1 here. But you have like the same identical formula, just with the round, right? So that means like 2 of the formula equals that. So that's why we divide by 2. I hope that makes sense. But yeah, so that's what we have to do. Well, but now when we have like 4 elements, we want to sum from 1 all the way to 3. So if we have n elements, we want to sum from n all the way to n minus 1. So if we just apply the formula, well, what do we have? We have we actually have n times n minus 1 divided by 2. So that's the number of total pairs. And we want to count the good pairs as well. So we want to find the good pairs down here. We just want to get for frequency in frequency mapped nums dot values. We only want the values. We don't really care about the actual value itself. We just want the frequency basically. Yeah, so good pairs. So we want to use the formula again, but instead of instead of n here, we'll just use frequency. Like we want to sum from 1 all the way to frequency minus 1. So that's why we just apply the formula again. And yeah, and at the end, bad pairs is just the total pairs minus good pairs. If I didn't write anything wrong, that should work. Let's see. Collections, I think. Yeah, nice. I think that works, unless I ran into some bugs. Oh, no, that works. Well, I think this question is probably on the harder side of normal, I think. Like, you have a lot more steps. Like, you have to think about rearranging the formula here, and then you have to think about like the arithmetic sum. But yeah, I think like this question is like it only has 10 lines of code. It's really easy to code it out, but then to come up with the idea is not the easiest. Well, but yeah, well, I think it took like 20 minutes. So it's still very doable, I think, this question. Yeah. Well, I'll see you tomorrow. Bye.